Welcome to another episode of Tech Exceptions. My name is Ruth Yakubu, and today we have an incredible startup joining us today. I have Rajib Saha, who is CEO of Parabole.ai, and also we have Anthony Sarkis, who is the Chief Strategy Officer at Parabole.ai. In today's session, we're going to be talking about how the company is optimizing digital twins using machine teaching and reinforcement learning. Gentlemen, welcome to the show. I am super excited to be talking to you today.
Thank you, Ruth. We're very happy to be here.
Awesome. To start with, Anthony, can you tell us what Parabole.ai is and what problem is a company trying to solve?
Sure. Powerball, simply put, is a cognitive analytics platform company. We have a machine teaching platform called Train. And what we've done is built something that organizes both the enterprise expertise with existing data. So what we're trying to build and what we've built is a computerized knowledge model, enabling strategists, experts within any large organization to make better decisions by getting a full view of all the information that exists inside the enterprise. So we'll get more technical, I would imagine, as we go further, but the way we do it is by discovering critical business knowledge from all information assets in the organization, from the customer all the way to the back office. We build a machine-readable model, and this way all stakeholders, data scientists, and experts are able to find answers rapidly against a new knowledge model that heretofore hasn't existed.
Awesome. So can you give us examples, maybe an example of a real-life scenario where Parabole was used, so it gives the users the context of how the solution works?
Right. So, Tony, I'm taking this question. So, we empower a range of large enterprises, which is realizing the full vision of this digital twin and enterprise industry 4.0 use cases at scale. So, if we take that industry verticals for the manufacturing enterprises, our Train platform help them to implement a single product view, product lifecycle management, or standardization of the different engineering products, or even building this knowledge graph, right? Enterprise knowledge graph. On the other hand, like other set of customers of us, like the banking and the financial service, or even the media houses, so they are using it for the different type of risk discovery. Say, for an example, somebody wants to discover that what are the potential vendor risks that they are dealing with, or even for the data governance organizations, kind of extracting that business metadata and creating a kind of active metadata governance layer on top of their existing data structure that we do. And also, like the other aspects of the utility of our platform is the regulatory defense. So particularly for the financial service organizations or any large organizations which requires this regulatory compliance. So they use our platform to just build this knowledge model of their operations, which they can use for the regulatory defense.
Wow, that's incredible.
So,
when I think, go ahead.
No, go ahead.
Okay. Well, when I think of an organization, whether large or small, when you're thinking of building a knowledge graph, that entails a lot of data because the data is embedded in maybe documents, email, even the application and whatnot. So how does Parabole grab all of that information and start creating some kind of relationship with the data to create like a data catalog?
Right. So, I would like to answer your questions in two parts. So first of all, the knowledge graph. So our definition of knowledge graph is slightly different from the convention. So in our language, this knowledge graph does not just mean like the different nodes and the connections across the different data elements. So we really consider that knowledge as a representation of these enterprise concepts, and also just kind of harmonizing these concepts with it underlying data through a high dimensional graph. And like the creating this high dimensional graph is not possible manually, right? So neither it is possible to just kind of deploy 1,000 ontologies to create an ontology, nor you can just scale up that whole development process to cover that entire knowledge spectrum. So what we did is we came up with our learning pipeline or our technique, which is covering to the different type of sources of these information assets within that organizations. Could be some structured data, could be some unstructured data, and then trained machine is capable of extracting this knowledge from there and create that structure, means create the structure which we call it as knowledge graph. And then the knowledge graph is basically just capable of utilizing this cognitive model to connect to the physical data set. Once that process is done, so then you have your high dimensional knowledge graph ready, which is machine consumable, but at the same time you have a low dimensional knowledge graph, which is kind of which we make it visible to that experts, like who can review that knowledge graph and provide that input for the further reinforcement. That is our technique.
Okay. So to make sure I understand what you're saying, you do have text from your data sets, and you're probably using text analytics to even understand what those texts are. So you're using Ontology to find relationships between those texts through machine learning, correct?
Well, okay, I think
that's right.
Yeah, it's right. Actually, we don't really create ontologies, not manually anyway. Rajib, why don't you talk a little bit about the differences between how we're discovering knowledge and building those ontologies on the fly?
Okay, awesome.
Right. So sorry, the network line was a little bit glitchy. So so Tony is right. So like I told you, right? So creating that ontology is we don't believe this is a manual exercise, right? Like if you look at the scale of this ontology, like which have been heavily used in this healthcare industry or this pharmaceutical industry for long. Like if you look at this scale, it's enormous. Mayo Clinic developed a oncology-based ontology. It took a couple of decades, right? So now, if you want to just develop this ontology for an enterprise, nobody has a patience or enough money to just kind of spend 10 years to build that ontology. Right. So in our case, we split our machine is trained to do the two things. One is that knowledge discovery, right? Which is basically just going after all these assets and finding out that knowledge from there. And that's the hard part. And once that knowledge is discovered, so then you have to stitch that knowledge in a proper structure, right? So that is basically a formal ontology. So machine, that's an easy part. Machine takes the discovered knowledge and automatically puts that in ontology. So in this process, we made the whole process automated, right? From the discovery to the presenting that knowledge into that ontology structure, and it reduces the ontology development effort by 99%. I just leave that 1% for the validation, which is basically like the reinforcement of the ontology.
Okay. Are you using neural networks throughout the whole process, or are you using any open source technologies with the discovery process?
Right. So, like Tony has mentioned about our main platform, which is Train, right? So Train is a machine teaching platform. So we call it as a machine teaching platform. But if we just dive deep, it's a combination of the three different core technologies. We call it as the three different pillars. One is the machine teaching, right? Where machine is kind of been taught by an expert just by providing the directives. It does not need any training data. The second part is reinforcement learning, right? Like when that machine is learning a particular domain, subject matter expert or that a business SME can validate that machine's output or learn accuracy, and then helps it to kind of reinforce that learning. And the third part is, as you said, yes, we do use neural nets, and we are using actually multiple layers of this deep learning and designated for the various type of work.
Okay. And you mentioned reinforcement learning, which I find it odd because usually when most people that use reinforcement learning, It's usually used for gaming to figure out the most optimum route or path to play a game. So in your situation, how are you guys using reinforcement learning? Because as you go through the neural nets, each iteration has to have an optimum score, and is a human being involved to assign that yes, with this path it did go through and successfully find a relationship, or no, it didn't do right, so it has to go back and relearn. How do you guys utilize reinforcement learning in a data relationship creation type of mode?
The biggest challenge for this reinforcement in our experience, the biggest challenge is the scale. Like when you are discovering this knowledge for an enterprise, it's a humongous scale, right? So if you take that ontology or this knowledge graph, we are talking about say 10 million nodes, 20 million connections, and it is impossible to just kind of review all the nodes and connections manually, right? So you have to just you have to just be very strategic and smart to just kind of do this validation. So what we do is that's why I was explaining you that high dimensional knowledge graph and low dimensional knowledge graph, right? So when we are talking about this low dimensional knowledge graph, like which is I'm reducing the dimensionality and making so that it becomes like kind of manageable for this visual inspection, right? So our SME looks at this low dimensional knowledge graph, which is visible, right? So he or she can validate one particular node or one particular connections. And now I'm talking about a range of say 100 to 1,000, not a million. So now that correction goes as an input to this machine once again. So the machine takes that as an input and applies that into the high dimensional graph. So then automatically it corrects this million nodes and kind of, I would say in many cases, like 100 million connections automatically. And this whole process, like the secret, I would not say secret sauce, but this is smartness that we applied in that machine teaching under reinforcement, just reducing that overall knowledge to a lower dimensional space.
Okay. So you go through the ontology process of taking the data, trying to find the relationships, going through reinforcement learning to try and figure out, okay, how does all of this stitch together and what are the optimum relationship or linkage between the data? Where does the digital twin come into place? How do companies use the digital twin simulation to leverage the knowledge graph that is produced?
Right. So when it comes to this digital twin, the conventional approach for this digital twin, or I would say the concept for this digital twin is basically asset based. You're taking an asset, a physical machine, and creating a twin for that. Like this is definitely very interesting. But when it comes to this enterprise, one machine doesn't make an enterprise as a whole. So the point is like an enterprise is a collection of the different critical business functions. The north is like if you can create a twin for an engine or a machine, why can't you create a twin for the whole enterprise, right? So it sounds fictional, but the point is like we are applying the same fractal-based approach, right? We are taking the smaller functions or the smaller subdomains of this particular enterprise and getting machine trained on that particular domain. And now all these models that machine is producing, they're completely pluggable. So you created the submodels for all the domains and then stitch it together and automatically it creates a big cluster. So then that becomes that enterprise digital twin. So we started with this conventional digital twin to start with. So now you're getting a great response from our customers, particularly from this manufacturing and this logistics industry, to create this enterprise digital twin. And it is driven by the business benefits. So now once you can create this business enterprise digital twin, it can power many of the different logistics intelligence or insight discovery, which erstwhile was not possible through that conventional data analytics.
Okay. And the whole point is to discover these insights in order to make better decisions or come up with better strategies on how to handle, maybe, let's say you get a new product and or a new part in a manufacturing scenario that you're talking about, but you don't know how well it's going to perform or how it's going to break things. So before you go and invest your money, you put it through the digital twin simulation to see the outcome of what's going to happen before you go and spend your dollars and deploy this in real life.
Absolutely.
And when that's enriched by all of the information, all the processes, procedures, anything that we would generally term unstructured, and when that's connected to the actual data from what everyone understands is the current version of a digital twin, it speaks directly to the users, right? It speaks their language and allows them to do that simulation much more efficiently and much quicker.
Okay. So with a manufacturing scenario, makes sense. Totally understand. Another industry that I'll probably see this used is maybe financial, the financial industry. Let's say there's a new government regulation that companies need to change their model. Maybe they need to go through their documentation, update things. Maybe they actually created models that were using the prior government regulations or change their applications. How does your solution come into play? If you're going to add something new to an existing model, do you go through the whole ontology phase of figuring out, okay, the relationship, coming back to the reinforcement learning part of, okay, let's look at this web of knowledge graph that it has to see all the optimum relationship that this potentially new addition is going to lead up to. Is in that scenario, would that be what a financial institution will use in terms of making a decision to figure out where to start implementation?
Right. So, a very important concept that you just mentioned, right? So first of all, when we are discovering this knowledge, and knowledge is not static. If we are thinking about creating a static knowledge model, so this is a failed approach. So at point in time, when you are discovering this knowledge, that remains like kind of contemporary, but it is our philosophy is making this knowledge model ever expanding, like based on that the changed input, based on that the parameters, or this based on these environmental inputs, it keeps on kind of growing on its own, right? But it definitely needs some kind of governance. So knowledge governance comes into the picture. So now that said, the enterprise digital twin, typically it is a manufacturing or CPG business kind of this aligned to that business. But the point is like why not in financial service? The same concept. Financial services are kind of organizations are complex business entities, right? So there are a lot of different functions. So the same logic we apply to this financial service sector as well. So now, when you say that regulatory functions, when a new regulation comes in from that regulator, right? It's an external information. So we are basically training this machine or to understand a particular regulation in a particular domain. Say it's a regulation is related to credit risk. So now the machine is trained to understand that credit risk management. So it does not take much time for the machine to explain this credit risk related regulation in one hand. That on the other hand, when machine is analyzing this credit risk operation or risk management of this bank, so then it can basically do this mapping, that it can find that okay, this newly newly introduced regulation is going to impact such and such sections or the such and such products of this bank's credit risk management, right? So that is
Right.
the whole methodology that we follow.
Okay. So one thing about the complexity, dealing with the complexity of the data and the relationship that you're trying to uncover, and also the risk involved in, let's say you're to bring something new, that looks like a lot of processing power, especially for reinforcement learning. That entails a lot of processing cycles, and it'll take a very long time. So in my head, I'm wondering, how does the deployment work? If you're to work with a brand new company, is that going to take months before you guys deploy it to a new corporation that has loads of data that you're trying to find relationship between the data, or even understand the workflow, end-to-end dependencies?
So that's a smart thing. So Tony, why don't you answer this one? So I can see that you are smiling. Like this is one of the USP, but I want you to answer.
Well, we had, when we got Powerball, when we developed the platform, we knew that we had a couple of big boxes that we had to check off. And one of those was speed to deployment. For example, we have a large manufacturing client that presented the problem to us. And 2 weeks after they presented the problem to us, not only had we executed the POC, we had actually delivered the output. So the way that we've constructed the model to get to a full deployment is something we talk about in terms of a couple of months. But in order to do an experiment, let's say, for any customer, we're able to do that very quickly. So when we work behind the scenes and we train the machine, then it's deployed on the customer's Azure tenant. They're seeing output very quickly, and that output has been, thankfully, very positive. And so we've been able to move very quickly through a client relationship to the point where, in 3 months, we're not only talking about the deployment of the first, let's say, experiment, we've now worked on 2 or 3 more use cases for that customer. So we've solved the time issue. And when we started this, I mean, a little anecdotally, we started this with rack servers on our own premises. We had to be efficient by design, and now we have the luxury of working with Microsoft. So while we're not flippant with the use of processing power, we're still very quick to deployment.
Yeah, I'm curious, are you guys using the Microsoft reinforcement framework for your architecture to help speed up the processing?
Not yet. So our reinforcement pipeline is Parabole's unique pipeline. But going forward, so we are in discussion. So one part of that reinforcement learning, like which Microsoft is taking care of, like this IoT based learning part. So this is where we are in discussions with Microsoft to just kind of bring in the Microsoft's reinforcement learning framework.
Yeah,
but
because
great opportunity. Like if we can do this, like we are covering this entire spectrum, right? So we are covering this enterprise. The other part is covering the system integration or systemic digital twin part.
Yeah, because this is a very big bottleneck for anybody that dares to dive into the reinforcement learning realm. And it's interesting that more people are diving into reinforcement learning, because before we're used to the traditional machine learning, whether it's supervised or unsupervised machine learning or deep learning. So it's interesting to see that you guys are using reinforcement learning, but not in the conventional gaming route, but in such a clever way for a digital twin type of scenario. I know we have 5 minutes left. Another question I have is, since you guys are able to collect a whole data catalog within a company, are you guys also using Azure Cognitive Search? Because you've mined all the data in one place. Are you guys using that at all into discovering content?
Yes. So we are using a number of different Azure services, and depending on the different problems that we are solving for the different customers, right? Azure Cognitive Search, yes, we do. Like wherever we see the diverse set of data and the documents that we need to just kind of make it enable for enterprise search level, we are using that. At the same time, while we are using this enterprise cognitive search for this from Azure, we are also using that other Azure services like Azure Storage, Azure Indexing Service, like means which are related to this cognitive search part.
Right.
But that is
Okay.
like only a kind of tip of the iceberg. But from
Okay.
the platform level, like we are using a number of different other services like the Azure HD Insight and all Kafka and all the other services like that.
Oh, okay. For the input stream that comes in.
That's right.
Okay, that makes sense. Well, it looks like we're at time. Do you have any closing words for the audience?
Yes. So I would just go first.
We have a
You're
little bit
cutting
of
out.
we have a little
I
breakup.
would say
Rajib.
Tony will just
Sure.
this industry. Hello.
Okay.
Yeah, Rajib, you're cutting off. I think we'll
He
go
cut
to
off,
Anthony.
So I mean, for us, we think that the evolution of the digital twin brings so much more applicability when it's evolved into the enterprise digital twin. We think that was inevitable. We feel like we're there very early with actual deployments. The benefits of discovering and modeling using all the data in any enterprise should be very clear. So, what in just a few months, we've been able to, have deployments from entering the market in late 2019. What we can say to anyone who has interest in this topic is, we've been able to complete full experiments in several days. We've built our platform on Azure. Our integrations and deployments are very fast. And, so people understand when we meet clients, we go in as, Powerball with Azure. And so from our standpoint, what we've learned about customer interactions through the Microsoft relationship has been very powerful. And all of our clients are very large clients. We are really happy to talk to anybody about any client they have. But, I would ask, the more complex the problem, the better it is for us. So there are pain points out there that customers have. If you can think of a use case based on what we've talked about today, it's worth a phone call. It's worth having a conversation about it.
Okay, excellent. Well, this was an incredible conversation. You guys opened my mind to the possibilities of different things you can do with data. I appreciate you guys being on the show, and thank you for coming to the Tech Exceptions show.
Thank you so much, Ruth. We really appreciate it.
Thank you.